Hello everyone. So in today's video we're going to talk about Keras. So this video is for you if you have literally no knowledge at all and you just heard about it, or you are from non-technical background but are interested towards this field. And even if you know a little bit, this will give you a little more insight into Keras, and it's kind of like an overview. So let us begin. We will be discussing about Keras, basically what it is, and all those kinds of details. Then we'll talk about its features. It has a variety of features and we'll see about them one by one. The advantages, applications, and then how to build a model in Keras. So basically an overview of the step-by-step procedure or the kind of things that you have to do to build a model in Keras. So what is Keras? So Keras is an open source high-level neural network library which is written in Python, and it is capable to run on Theano, TensorFlow, or CNTK. So CNTK is nothing but it is Microsoft Cognitive Toolkit, which was earlier known as Computational Network Toolkit. So it is a deep learning framework, and framework is basically reusable pieces of code which is written by developers to help solve various problems. And it's kind of like a library, but framework is used for building and deploying of applications quickly. So an open source library is basically a library with an open source license. That means that anyone is free to reuse the code or modify it or even publish it without the permission of the creator. And a neural network is a method in artificial intelligence where it tries to teach a computer, uh, the way our brain handles data, or it tries to replicate the human brain. So we saw what neural network is, and this is a pictorial representation of it, a very basic neural network. In this you can see two layers. So this is the first layer, or it is also known as the input layer, since input is fed from this layer. And then over here this is the second layer for the picture shown, and this is the output layer. So this is the very basic neural network. Like you can see, there is no other layer in between these two. If there would have been another layer, it would have been called a hidden layer. And there are different calculations that take place depending upon what the network is made for. So in this neural network, if you see, we have +1, x1, and x2. So it means that there's two variables, x1 and x2, and then there are coefficients of these. So 20 is the coefficient of x1 and 20 is the coefficient of x2, and -30 is just constant. That's why we have written +1 over here. So basically what this function, it is doing summation. Over here you are multiplying each one and then you're doing summation as g of z, and finally you'll get this equation as the output. So over here, if you do -30 into +1, you get -30, which is written over here. x1 into 20 is 20x1, x2 into 20 is again 20x2. So g of z is just doing summation. So it's pretty basic neural network, like I said. And finally this equation is your output. Now once you provide values for x1 and x2, you will get a constant value out over here. So we can see another example with a hidden layer. So in this, now you can see that there are three layers in all. The first one is labeled as input layer, like you can see. The second one is the hidden layer, and the third one is the output layer. So in this picture, what we are doing is we are taking certain features like area in feet square, bedrooms, distance to the city in miles, and age. Now, just by looking at you, you can tell that these must be the features of a house maybe, or yes, a house. So all these features will in the end help you determine the price of the house, which will be your output. Now there is a hidden layer. Now how do you use this hidden layer? So firstly you'll have to see the arrows, which arrow is connecting where. So in this specific neuron, area and distance is being fed. So when you're feeding area and distance over here, so it can be something as simple as multiplication. Now there are so many mathematical functions, there are so many calculations or different ways of doing things in maths. One of the very basic thing is just doing multiplication. You can take log, you can take exponent. There's a lot of things, but uh, you have to decide what the neural network is and which one will be the most suitable for you. That is something which can be done later on with practice. And over here in this example, let's just think of this layer as a multiplication layer. So whatever is coming into this, it is multiplying it simply. So area and distance, so it will multiply area and distance, and we'll write it here. Then for this again there's two inputs, which is number of bedrooms and the distance. For this third one over here is bedrooms and age as well as area, all these three. So you can multiply these three and write it here. And for this one again there are three incoming arrows, like you can see, one is area, one is bedrooms, and the other is distance to the city. So once again you can multiply and write it here. And for this there is just one, so you can directly write age as it is. For the final one now, again we can take a simple operation as addition. Now all these values over here which you received after multiplying the input layer, the few neurons of the input layer or the few inputs on the input layer, depending upon which one is connected where. So just add all of them and you will get a price. So that can be one approach over here. And they have specifically not mentioned anything in the hidden layer, because any kind of function can be used over here. It is up to us what to use, how to define it. And like I said, this is just another example like the previous one, but in this we also have a hidden layer where there are more calculations performed, and the input layer and the output layer, and finally in this you'll get an output as the price. So Keras is made user friendly, it is extensible and modular for facilitating faster experimentation with deep neural networks. So when you are working with Keras, there will be deep neural networks, and usually there is, when you're working with deep neural network, there is a lot of time that is taken by machines. So what Keras does is it facilitates faster experimentation. And deep neural network is basically a neural network with lots of layers in between the input and the output layer. So this is how a pictorial representation of deep neural network would be, where this is the input layer. You're giving inputs, various inputs. Each one is connected to uh, neurons from the next layer. So this can be the hidden layer 1, and then there will be multiple layers. In this we have just 3 hidden layers, and then the output layer. So this is what a neural network looks like, or more specifically a deep neural network, since it has multiple hidden layers. Now features. So Keras is an API designed for humans. So what is the API now? API stands for Application Programming Interface, and it is like a software with a distinct function. So it is an interface basically, which can be thought of as a contract or a service between two applications. So this defines how communication is done within two applications, using requests and response. Now you'll better understand it by looking at this diagram. So if there is an end user with a browser or an application, or something similar, The user will request some kind of data from the API. Now this API will then fetch this data from the backend, from the database, from the server, and after fetching it, it will provide it as a response to the end user. So this can be, analogous to the real life waiter. So when you go to restaurants, now you're a customer, you're just going to sit on your table, you're going to look at the menu and you're going to make an order. Now once you make an order, the waiter will take your order and he will go to the chef, or he'll just pass it on to someone else. You do not know what is happening in the back because you just give your order to the waiter and you're just waiting there. So the process happens in the back end. The waiter will pass on the order to the chef. Your order will be prepared and the waiter will bring it back to you. So that then it will be the response or the delivery of the order. So the waiter in this scenario is the API, the interface between the customer and the kitchen, or from where the food is made. Now, Keras is also very easy to learn and use. So it was made to be simple and it offers consistent and simple APIs. So it reduces the actions required to implement common codes and explains user error clearly. Now, when you're implementing a common code or something that is going to be used a lot of times, so it is not at all messy. It is very easy to implement these codes. And if there is an error, in case there is, it also explains the error very clearly so that you can easily debug it and you can make corrections. So apart from that, it is also highly flexible. Uh, Keras provides high flexibility to all of its developers by integrating low-level deep learning languages such as TensorFlow or Theano, which ensures that anything written in the base language can be implemented in Keras. So all these might be a bit new to you, but then if you just try to understand the feature that it is flexible and even it can be integrated with low level deep learning languages, so it is a plus point. So a level language basically means the computer's native language. So it's sort of a programming language which is very close to writing actual machine instructions. So when you are writing a code, and what machine interprets are two completely different things. If you're writing a text, if you're writing anything to the machine, it is changed, and the low level language will look something like this in binary. So high level language, whereas, is the code or the text that we write, which can be readable by the user, but low level language is readable or understandable to the machine. So yes, it works to control a computer's operational semantics. So let's move on to the advantages. So Keras supports multi backend, which means you can use any one of TensorFlow, CNTK, or Theano with Keras as a backend according to your requirement or your convenience. Now, when you look at this, so Keras usually does not work independently. So like I said, you can take any of these as a backend for working with Keras. So it works like an upper layer for the prevailing deep learning frameworks. So like TensorFlow and CNTK, Theano. So Keras basically it acts like a wrapper for these frameworks. It supports data parallelism, which means it can be trained on multiple GPUs. We'll see what GPU is, and this will really speed up the training time and the processing a huge amount of data at the same time. So data parallelism means same operation being performed concurrently in parallel on elements in a source collection or array. So if you're training the model, just think of it as increasing the resources in the backend. So if you're training a model and there is just one CPU, so you can just think about it that it will be slow. It will be pretty slow if you're doing something. If there is a huge crowd and there is just one person to serve the crowd, it will be slow. But when there are multiple people serving the crowd, concurrently, it will be very fast. So this is what Keras does. It allows data parallelism and a GPU or a graphics processing unit. So it is a computer chip that provides graphics and images by performing rapid mathematical calculations. So this is a representation of how data parallelism works, where you have the input data in the form of an array, let's say, and each bit of that an array or each segment of that array is given to a task. Now the same task is done in parallel, and each of this task will provide some kind of a result. Now these these results provided by each of the tasks which ran in parallel will be aggregated together and the final result will be provided. So let's just go through it once again. So the input data in form of an array, each segment of that array is provided to a task or is processed in parallel, done at the same time, and each of these tasks will be providing a result. Now this result will again be looking something like an array where each task will give a different result, and then you aggregate that result from all of these and then you provide a final output. So that is what data parallelism looks like. Now another advantage is that it is very easy to understand and incorporate the fast deployment of network models. So now what do you mean by network models? Now you can understand that faster deployment means that it is obviously faster and it is easy to understand as well. Now a network model is something like an e-commerce website uh, where there is a customer, the customer places an order, there is an order line, so there is a product, there's a shipment. So when you can form kind of a network, if you look at it, it kind of resembles a network where there's interconnections between various entities. So that is what a network model is. So applications, Keras is used for creating deep models, which we already know now by now, and it can be productized on smartphones. So it's used by companies like Netflix, Yelp, Uber, etc. So all these companies are using Keras for the deep models which they have built. Now, how do you build model in Keras? So to build a model in Keras, you first have to define a network. So in this step, you define the different layers in our model and the connection between them. Then you compile a network. So to compile basically means to convert it, to machine level language, or in such a language where the machine can understand it. Then fit the network. So once you have compiled the network, you will now fit our model, or fit our model to our data after compiling. So this is used to train the model on our data. Then you will evaluate the network. So after fitting our model, we have to evaluate the error in our model, and then you will make predictions. So a model.predict is the technical code or the line which will be used to make predictions. Now this was a bit more complex to understand. So if you just look at this diagram, so first you will define a network. You will be defining all the layers, and then you will compile it. Then you fit it to the network, you evaluate the network, you make predictions. So it is as simple as that. And even though it might seem a bit lengthy, with Keras it is actually very easy, and it saves a lot of time. So that's it from this video. Thank you so much for watching.